So WS security, from a SOAP standpoint anyway, is the standard that we see most people adopting. I guarantee you in this audience, I know today I've seen at least 2 or 3 of the original authors of the WS security spec, so they can speak to whether WS security is addressing what they felt it should when they wrote these specifications about 5 years ago. But what we tend to see is a lot of people think about using this to encrypt and sign SOAP messages, which is okay in some aspects. What we're starting to see more of is the second half of that spec in terms of what it was designed for, and that was to allow security tokens to be included in those SOAP headers, where those security tokens are used to represent the identity of the calling application or even the end user, but it's represented in a trusted fashion through security tokens like predominantly the SAML tokens that we see today. But what was left out of the WS security specification really was where do you get those security tokens from? They profiled how you might convey a SAML token or a Kerberos ticket or an X509 certificate in WS security messages, but they really, they left out deliberately how or where you might get those security tokens from and how or where you might validate those security tokens as well. So that's where, in their components-based model, they built on a specification called WS Trust. It's another OASIS standard. It's part of a WSSX committee. It's an extension of WS security, and really this enables security token exchange between web service clients and providers, and a role called a security token service that's defined in the WS Trust specification. The STS, or security token service, is there to issue SAML tokens and validate other tokens like Kerb tickets, passwords, certificates, etc. You'll actually hear Microsoft evangelize the notion of this STS a lot in relation to things like information cards, claims-based processing, things like that. It's one and the same thing. One of the advantages of standards is everybody can build to the standard, and that's what we've been doing. WS Trust is also the basis for some higher level specifications like information cards for one, WS Secure Conversation is another. There's a couple of others out there I can't remember off the top of my head, but it's actually a nice building block for building out additional capabilities. What we've done is taking it at its basis, essentially, and are looking to just leverage that core specification to do some fairly simple things that become quite powerful in the context of web services. So, as it relates to SOAP APIs and SOAP-based web services, what we're finding is people are defaulting to wanting to use the SAML token profile and conveying SAML tokens in their SOAP messages and in their web services messages. This allows them to communicate information above and beyond sort of the organization this message might have came from, to actually include user information, to include the application that that's invoking this request, and additional sort of attributes that might be also associated with that application or that user. This gives then the web service providers a little bit more granularity control, as I mentioned before, for making authorization decisions based on that information. So the STS in this case actually implements sort of fairly common federated identity concepts that you'll find when you talk about federated web SSO and things like the SAML 2.0 specification or the WS Federation specification. A good example here is an organization that's acting as a web service client, and it needs to include which application is making certain requests into the web service provider. These SAML tokens can all be signed by a single certificate that represents organization X, say in this case, but the web service provider is able to sort of make some granular decisions to say, well, it's all right, I trust organization X, but I only want to expose this API to these 3 applications, but not these other 4 applications, things like that. So we're seeing a lot of interest in that regard because it allows the people to shift to, as I mentioned before, more granularity in understanding who is calling these web service providers. So the advantage of the STS really gets to centralization of security token processing. You can pull out crypto out of the applications. A lot of the issuance and validation of tokens can be handled in a common service. It sort of starts to enable single sign-on between web service clients and web service providers, things like that. The sort of analogy I've used here is that if an STS is issuing SAML tokens to allow applications or users to get in to applications without having to sort of authenticate with a password, that really, it becomes a fairly important piece of infrastructure, as you can imagine, because it's, if these tokens can be, stolen or, whatever it might be, it's giving people access to these apps without having to re-authenticate. So, creating these SAML tokens or being an STS within every application is sort of, the analogy I've used with some people is like saying you're going to build a CA into every application so that it issues its own certificates. Not generally seen as, best practice over the last few years. So that's what we're seeing from a sort of SOAP standpoint. I mean, hands up here, who's heard of the OAuth protocol? Given Eric mentioned it earlier on in the panel on different federation standards, I'd hope so. That was Eric Sachs from Google. So this is the other side of the fence. So we see a lot of stuff happening in the SOAP world. We're also seeing a lot of stuff happening in the REST world. Up until very recently, really till till OAuth has materialized in the last 12 months or so, there hasn't been a standard I could point to say, here is how you secure your REST-based APIs. Really, most people have been on their own, and they might have done things like mutually authenticated SSL or HTTP basic or things like that, common HTTP or sort of TLS mechanisms for doing authentication. But with OAuth sort of being driven in by the SaaS and the Web 2.0 community, we now have something that we can start to look at to address some of how you might secure REST-based APIs. OAuth really is all about handling delegated web service authentication. It helps you secure those APIs, providing secure access, things like that. All right. There's a couple of flavors of OAuth I thought I'd go into. This is the simpler one. It's called two-legged OAuth. They need a marketing department to come up with something better than that, but this is what's out there. This is what it's called today. The analogy here, I would say, is it's equivalent to how you might sign a SOAP message with an XML signature. It effectively provides the same level of capability. What you're doing instead is signing a REST-based API call and creating a signature over that with some keying material that's been exchanged out of band in some way. And that can be done through HMAC or it can be done through RSA from a signing algorithm standpoint. But you've got this out-of-band exchange of keys that are occurring. So this is what Google is currently defaulting to as the sort of standard way to secure its API calls when you want to make API calls to Google or Google's going to make API calls to you. This is something we're also seeing a lot of across a number of the other SaaS applications like Salesforce.com, where because they're so REST API oriented, they are sort of defaulting to use OAuth as the standard security protocol for securing those APIs.